Hi guys, welcome back to my channel, and today I will be doing Chemistry Paper 4, May-June 2022 Paper 4-3. This paper is 1 hour and 15 minutes long, and the total marks is 80. Okay, so let's start. Question 1. A list of substances is shown. Answer the question using the substances in the list. Each substance may be used once, more than once, or not at all. Okay, so First question, state which substance is a product of respiration. Okay, so should be quite simple. Respiration is glucose plus oxygen, giving you carbon dioxide and water. Okay, therefore, in the products, there's only carbon dioxide present in the list. So therefore, the answer has to be carbon dioxide. Okay. And next, the main constituent of hematite. So hematite is the ore of iron. So this is the ore they dig up from the ground for iron. It was known as hematite. So therefore, the only iron containing compound is iron oxide. Therefore, the answer for B is iron 3 oxide. Okay. C. An element which has sulfate that is used to test for water. Okay, so as you know, the test for water can be cobalt chloride or copper sulfate. So therefore, there's no cobalt here. So therefore, the only answer has to be copper sulfate. So the element which has a sulfate that's used to test for water would be copper. Copper sulfate is blue when there's water and is white when there's no water. Okay. D. A colorless toxic gas. So in this list, there's only two toxic gases. There's only carbon monoxide and chlorine. So chlorine is a green gas. So therefore, the only colorless toxic gas is carbon monoxide. It's a reactant in fermentation. So fermentation is just anaerobic respiration in yeast, right? So when you anaerobically respire, one of the reactants you need is glucose. So therefore, the reactant is glucose. Okay, a reducing agent in the extraction of iron. So whenever you want to extract iron, you need to put it in a furnace. You need to put the iron ore in a furnace with calcium carbonate and carbon, right? The carbon is used to reduce the iron oxide. So the carbon, which is known as coke, will actually react with the oxygen in the air in the furnace to form carbon monoxide. And this carbon monoxide will react with the iron oxide to form pure iron. So therefore, a reducing agent would be carbon monoxide. A conductor of electricity when solid. Okay, there's only one solid electrical conductor here, which is copper, because copper is a metal. Okay, a gas, there's approximately 21% of clean dry air. Okay, so 78% be nitrogen and 21% will be oxygen. Okay, and therefore the other 1% is the rest. Therefore, 21% of clean dry air would be oxygen. Okay, question 2. These two are isotopes of sulfur. Use your knowledge of protons, neutrons, and electrons to answer the following questions. Describe how these isotopes of sulfur are the same and how they are different. Okay, so this question is 3 marks, so you have to talk about the protons, neutrons, and electrons. So in isotopes, the similarities are they have the same number of protons and electrons. Because in isotopes, the only difference is that the number of neutrons are different. Okay, so in this case, you'll both be 16. But in this case, this isotope on the left only has 16 neutrons, but the isotope on the right has 17 neutrons. So 16 compared to 17, 17 has more than 16, right? So that's the difference. Explain why each of these isotopes have an overall charge of 0. It is because number of protons which carry a positive charge is equal to the number of electrons which carry a negative charge. So in the case of the first isotope, if you have 16 protons, which is 16 plus charges, and you add it with the number of electrons with the 16 minus charges, you get a net charge of 0, right? Explain why both isotopes have the same chemical properties. It is because the number of electrons are the same, so therefore the valence electron have same number. They have the same number of valence electrons or outer shell electrons, which determines the chemical properties of the isotopes. Okay? B. Sulfide ions have the electronic structure of 288. Explain why sulfide ions have a charge of 2 minus. They have a charge of 2 minus is because they have 2 more electrons than protons. Okay. And I give the formula of an anion which has the same electronic structure as S2 minus. So you know the electronic structure of S2 minus is 288. So we need to find another anion which is a negative ion that has also the same electronic structure as this. So one example would be chlorine minus. See, it has a minus, so it's an anion, and it has the same electronic structure because a chlorine element has the electronic structure of 287, but if you give it one electron, it will become 288. Okay? A cation which has the same electronic structure as S2 minus, we can put K plus, okay? Because potassium originally has the electronic structure of 2881, but since it has a plus, you give away one electron. So after you give away its electron, you become 288. Therefore, this can be potassium ion. Okay. Question 3. This question is about nitrogen and compounds of nitrogen. Nitrogen molecules have the formula N2. Some properties of nitrogen are shown. Melting point, boiling point, non-conductive electricity when solid, insoluble in water. Name the type of bonding between the atoms in an N2 molecule. So this would be covalent. Okay? Because there's you're bonding between two non-metals. Non-metal and non-metal. Since nitrogen is a non-metal. Okay? Explain in terms of attractive forces between the particles why nitrogen has a low melting point. Because intermolecular, so basically between molecules, forces are weak. Okay, so they have weaker attraction forces between molecules. Intermolecular forces are weak, so therefore it's very easy. They require very little heat energy to break these bonds to convert into a gas, right? Explain why nitrogen does not conduct electricity. So in order for something to conduct electricity, it needs to have free moving ions or nitrogen does not have free moving ions or mobile electrons, so therefore it does not conduct electricity. Okay. B. Nitrogen reacts with hydrogen to form ammonia in the Haber process. State essential conditions and write the equation for chemical reaction. Okay. I'm going to write the equation first. It's going to be N2 plus 3H2, reversible reaction, 2 and H3. Okay, so this is the chemical equation, and the conditions would be 450 degrees Celsius at 200 atmospheres of pressure with an iron catalyst. 4 marks. Okay. Ammonia is made in the laboratory by heating ammonium chloride with calcium hydroxide. Balance the chemical equation for the reaction. Okay, so whenever you're balancing equations, you want to make the left side equal to the right side, right? So first step we can do is, let's see, since they already standardized that you only need 1 calcium hydroxide, we can say that the left side will have 2 oxygen, so the right side needs to have 2 oxygen also. Therefore, there has to be 2 water molecules. And afterwards, let's see. It says here there's 2 chlorine molecules on the right side. So there has to be 2 chloride molecules on the left side. So therefore, this has to be 2. And finally, since there's 2 and here, this has to be 2 as well. Therefore, this is the final balance equation. D. Hydrazine is another compound that contains nitrogen and hydrogen. Complete the dot and cross diagram. Okay, show outer electrons only. So, nitrogen is in group 5 and it can form 3 bonds. Hydrogen can only form 1 bond. Okay, if since nitrogen is in group 5, means it has 5 total valence electrons. Okay, so in this case, see that nitrogen can form 3 bonds, so it will donate 1 electron to each bond. So it will look something like this. Okay, where you see for this nitrogen molecules, the electrons are represented as the X. In these nitrogen molecules, the electrons are represented by the circle, and you see that with each hydrogen, there's 1 bond on each between each nitrogen and hydrogen. Hydrogen form 1 bond only, and nitrogen forms 3 bonds. But since it can only form 3 bonds, there will be 2 electrons that are unbonded. So there will be 1 lone pair on each nitrogen molecule. Okay. E. Ammonia and hydrazine are weak bases. The chemical equation for the reaction between 1 molecule of ammonia and 1 molecule of water is shown. State the meaning of a base. It's very simple. Proton. A base is a proton acceptor. Okay. An acid would be a proton donor. Write a chemical equation for the reaction between 1 molecule of hydrazine and 1 molecule of water. Okay, so this question is basically asking what happens when you add hydrazine to water. And since they tell you it's a weak base, it will dissociate in water and you will accept a proton. In this case, a proton would mean a H+. So you accept a H+. So therefore, N2H4 plus H2O. Since it dissociates, it's a reversible reaction. N2H5 plus, since it accepts a proton. N2H5 plus. And the water will become OH minus. Okay. Next. Question 4. Ethanol is made industrially by the reaction of ethene with steam. The reaction occurs at a temperature of 300 degrees Celsius and a pressure of 60 atmospheres. A catalyst is used in this reaction. The forward reaction is exothermic. State what is meant by the term catalyst. A catalyst is a substance that increases the rate of reaction that remains unchanged after the reaction completes. Okay, so it speeds up the rate of the reaction, but is unchanged once the reaction is completed. Okay, complete the table using only the words increase, decreases, or no change. Okay, so in this question we have to use Le Chatelier's principle. Okay, we have to use Le Chatelier's principle, which states that whenever you change the environment around the system in an equilibrium, the system would want to bring down and oppose the change in the environment. So, if I were to increase the temperature, the effect on the rate of reaction would increase because the particles will have more energy, therefore they'll collide more, and therefore the rate will increase, right? However, the equilibrium yield of C2H5OH will decrease because the forward reaction is exothermic. So if we're going this way, it will be exothermic. So if we increase the temperature, it would favor the backwards reaction because the backwards reaction would bring down the temperature. Okay? Since the backwards reaction is endothermic. So therefore, the yield of C2H5OH would decrease. Now, decreasing the pressure would decrease the rate of forward reaction because there will be less collisions between molecules when the pressure decreases. And the effect of the equilibrium yield will also decrease because the backwards reaction has more molecules than the forwards reaction. So when you decrease the pressure, the system will want to increase the pressure again. So how to increase the pressure? You have to add more molecules. So therefore, the system would favor the backwards reaction if you increase the temperature, if you decrease the pressure here. Therefore, the effect on the yield would decrease. C. Ethanol is a member of alcohol homologous series. State the general formula of alcohols. Okay. CnH2n plus 1 OH. Okay. And state two general characteristics of all homologous series. So you can say that consecutive members differ by CH2. You can also say have the same functional group. And one more, you can say that they have similar chemical properties. Okay. One alcohol containing 3 carbon atoms is propan-1-ol. Draw the structure of the other alcohol containing 3 carbon atoms. Okay, so first step, it has to be 3 carbon atoms. So I'm just going to go draw 3 carbon. And they already drew propan-1-ol, which means the alcohol group is on the first carbon. So the other molecule this alcohol can be would be propan-2-ol, where the alcohol group would be on the second carbon. Remember, when you're drawing bonds, hydrogen can bond once, carbon can bond 4 times, oxygen bond twice. Okay, so if we double check everything looks correct. So this is the answer. Therefore, the name is propan-2-ol. Okay, you have to put the dash when you're naming, and since it's 2, because the OH group is on the second carbon. Okay. When alcohol react with carboxylic acids, esters are produced. Name ester X. So this should be quite simple. Mm, the number of carbons connecting to this O right here is 2, so therefore the first part will be ethyl. And the number of carbons connected to the double bond O is 4, therefore the ester is called ethyl butane. No, wait. Ethyl means 2, but means 4. Okay? Give the name of the alcohol and the carboxylic acid that react together to produce ester X. So the alcohol, the alcohol is the front part, so since it's ethyl, it will be ethanol. And the carboxylic acid is the back part, so butanoic, but, so it has 4 carbons, so it will be butanoic acid. Okay. Question E. Ester Y has the following composition by mass. Calculate the empirical formula of ester Y. Okay. Since they give you in percentage, we can say that this is out of 100. So out of 100 grams, 58.82 grams is carbon. Okay. 9.8 grams is hydrogen. And lastly, 31.37 grams is oxygen. So the first step, how to find mole? Use the mass mole formula. So mass over mR equals mole. Okay, so you divide everything by mR. So in this case, you divide by 12, divide by 1, divide by 16. Okay, so you would get 4.9, 9.8, and 1.96. Okay, so after you get the moles, you have to divide by the smallest mole to find the ratio, right? In whole numbers. So if you divide, in this case, the smallest is 1.96. So you take this answer, divide by 1.96. 1.96 divided by 1.96. Okay. And in the end, you would get 5. Sorry. You put it in your calculator. So 0.9 divided by 0.96. So this one you get 2.5 equals 2.5. So here you get around 5. Here you get 1. Okay, so 2.5 to 5 to 1. You need everything in whole numbers, so therefore the empirical formula would be everything times 2, 5 to 10 to 2. So you have 5 carbon, so it's C5, 10 hydrogen, H10, and 2 oxygen. And this is your final answer. Okay. F. Ester Z has the empirical formula C3H6O and a relative molecular mass of 116. Calculate the molecular formula of ester D. So this is a 1-mark question. It's very simple. First, you need to calculate the MR of C3H6O. So MR of C3H6O would equal 12 times 3, so this carbon, plus 1 times 6, so this hydrogen, plus 16. Okay, and which will give you the answer of, so this will be 36 plus 6 plus 16, will give you, this will be 22 plus 36, 58. Okay, so then since the MR of C3H6O is 58, from 58 to get 116, you need to do 58 times 2 because 116. Therefore, since the MR of ester Z is 116, you will need 2 C3H6O to make it 116. So therefore, you need 6 carbon, 12 hydrogen, and 2 oxygen for the MR to be 116 using the empirical formula. Okay, so the multiplier is 2, so therefore you take this molecule and you times by 2 for every atom. Therefore, the final molecule, the molecular formula has to be C6H12O2. Okay. Question 5. This question is about copper and its compounds. Describe the bonding in a metallic element such as copper. You may include a diagram as part of your answer. So, when you're talking about metallic bonding, you usually draw a bunch of circles. Okay, put plus inside. Okay, and then you would surround it by negative charges. So the negative charges represents the C of delocalized electrons. And then the plus represents the copper cation ions, right? So in this case, it will be a lattice. Lattice just means an arrangement, a large arrangement of positive copper ions, and you have a sea of free moving delocalized electrons, and therefore the metallic bonding would be the attraction, the electrostatic attraction between the cations and electrons. Okay. This. Okay. B. A metal spoon is electroplated with copper. State what is used as a positive electrode, negative electrode, and electrolyte. So the thing you want to electroplate, in this case is a metal spoon, will always have to be the cathode. Right? So spoon. Yeah, because if you use the acronym PANIC, okay, positive anode, okay, positive anode, negative is cathode. Okay, so the cathode is the negative electrode. Since copper is a metal, the copper in the electrolyte would then be attracted to the negative electrode since the copper ion is positive. Okay, so you'll be attracted to the negative electrode. Therefore, the thing you want to electroplate is always the cathode. So the thing you want to electroplate the item with would always be the anode. So in this case, it will be copper. I'm going to electroplate the spoon with copper, so the anode would be copper. And finally, the electrolyte has to be a salt of this metal. So in this case, it's copper. I can put copper 2 sulfate solution. Basically, it needs to be in solution form or aqueous. It can be any copper salt that can dissolve in water. Okay. C. The formula for crystals of hydrated copper sulfate is CuSO4 5H2O. Hydrated copper sulfate is made by reacting copper oxide with dilute sulfuric acid using these steps. Okay. So they want you to calculate the maximum mass of copper sulfate crystals that can form using the following steps. Okay, first step, calculate the moles of H2SO4 in 50 cm cube of 0.2 mole per dm cube of H2SO4. So first step, we need to convert this value into dm cube. So 50 by 1000 equals 0.05. Okay, yeah, it's 0.05 dm cube. Since 1 dm cube equals 1000 cm cube, right? So use this, divide by 1000, you get 0.05. So to find the moles of H2SO4, you need to do the concentration formula. So mole equals concentration times volume. So in this case, concentration is 0.2. Sorry. There you go. Okay, so concentration is 0.2. And you times by 0.05. Therefore, your answer would be 0.01 moles. of H2SO4, okay? Deduce the number of moles of CuSO4 by H2O that can form, okay? Since you're using 1 mole of H2SO4 in this equation to form 1 mole of CuSO4 that's hydrated, therefore, if you use 0.01 moles of H2SO4, you will also form 0.01 moles of CuSO4 5H2O, right? Since the ratio is 1 to 1, answer will be 0.01. Okay? The MR of CuSO4 is 250. Calculate the maximum mass of CuSO4 5H2O that can form. Okay? So, in this case, it's very simple. You use the mass over MR equals mole formula. So in this case, you want to find mass, so MR times mole equal to mass. So you have the mole, which is 0.01, times the MR, which is 250, which is 2.5. So your final answer is 2.5 grams. Okay. Step 1 observation that indicates the copper oxide is in excess in step 1. So let's see step 1. Is heated in a beaker, powdered is added until the copper oxide is in excess. Okay, so basically, how you know there's an excess? Since you're adding a solid into a liquid, you know there's in an excess if there is remaining undissolved solid. Okay, it's not a reaction, it's just you're just adding it until you can't add anymore. It doesn't dissolve, right? Step 1 is repeated without heating the dilute sulfuric acid. All other conditions are kept the same. The rate of reaction decreases. Why? Because when you're heating something, you give the particles more energy. The rate of reaction decreases because particles have less energy. So what happens when they have less energy? There's less collisions. Okay, and then less successful collisions because particles may not have, because less particles may not have, less particles may have enough energy to overcome deviation energy. So basically, even though the particles may collide, the collision may not be successful to instigate a reaction because the particles do not have enough energy to overcome the activation energy required for the reaction to occur. Okay. F. Name the substance other than copper oxide that can be added to dilute sulfuric acid to produce copper sulfate in step 1. So there's two things you can add. It can be either copper carbonate, or you can also add copper hydroxide. Okay, if you add either of these into dilute sulfuric acid, you would produce copper sulfate. Okay, copper 2 sulfate. Sorry, copper 2. Okay, name the process used to separate excess copper 2 oxide from aqueous copper 2 sulfate in step 2. So, since you are separating the solid from a liquid, you can use filtration. Just filter out the excess copper oxide. So just what is meant by the term saturated solution. So a saturated solution basically just means a solution that can't dissolve any more solute at that given temperature. So if the temperature doesn't change, it can't dissolve any more solute. The phrase heating to dryness means heating until no more water is given off. Explain why aqueous copper sulfate is not heated to dryness. This is because if you heat it too much, you will dehydrate the copper to sulfate. Okay, if you heat it too much, you dehydrate it, so it will no longer be hydrous copper 2 sulfate. It will be anhydrous copper 2 sulfate, which is a white precipitate. Not precipitate, a white powder, sorry. So why? Because you form anhydrous copper sulfate, okay, which is a white powder, okay, which is not what you want. Okay, last question. Question 6. Periodic table can be used to classify elements. Group 1 metals react with cold water. Transition elements do not react with cold water. Describe two other differences in the chemical properties between group 1 metals and transition elements. Okay, so chemical properties between group 1 and transition elements. So first chemical property is that transition elements have variable oxidation states. Okay, and transition elements can act as a catalyst. So transition elements have catalytic properties, and transition elements also have variable oxidation states, right? Describe the observations when potassium is added to cold water. Write a balance equation for the reaction. Okay, so whenever you add a group 1 metal into cold water, there will be a violent reaction because it's quite reactive, and you'll produce that metal's hydroxide. So first step, I'm going to write the equation first. Potassium, which is K in solid form, add to water, which is in liquid, you would get KOH, potassium hydroxide, aqueous, plus H2 gas, which is effervescence. Okay, next you balance. Here looks like I need so here there's H2, there's 3 hydrogens here, but there's only 2 here. Okay, I'm gonna add one more potassium. Okay, so that now there's 4 hydrogen on the right side. Here only has 2, so I can add 2 more here, and everything is balanced. Okay, so this is your equation. Observations can include fizzing, lilac flame, because when potassium flames are lilac in color, they are purple. And you can say effervescence, since the hydrogen is released, or you can say explosion, or you can say dissolves. Okay. Describe two other differences in physical properties of group 1 metals and transition elements. Okay, so transition elements are your typical metals. Group 1 metals are soft and squishy, and group 1 metals have a lower melting point. So one thing is transition elements have higher melting point, and transition elements have have higher densities. Okay, much heavier. Okay, some group 7 elements react with aqueous solutions containing halide ions. When aqueous bromine is added to aqueous potassium iodide, a reaction occurs. Describe the color change of the solution. Okay, so you can see here the bromine displaces the iodine. Okay, so when that happens, the original color of potassium iodide solution is colorless. Okay, so it's a colorless solution. Since iodide is released because of displacement, iodine is released because of displacement, the final reaction color of the mixture would be brown. Okay, because iodine in aqueous solution is brown. State the name of the general term given to a type of reaction in which the electrons are transferred from one species to another. So this is called redox. In redox, remember acronym oil rig. Okay, so I used to remember. Oxidation is loss of electrons. reduction is gain of electrons. Okay. Identify the oxidizing agent in this reaction. Give a reason for your answer. So we look at a half equation again. We can see that the bromine, Br2, is giving is causing the iodide ions to be oxidized. So therefore, it's the oxidizing agent. The oxidizing agent is reduced, and we can see here reduction is gain. So therefore, the bromine gains electrons to form bromide ions. Therefore, the oxidizing agent would be Br2, because it's Br2 is reduced, or you can say gains electrons. Okay. Okay, final question. Use the key to complete the table to show the results of adding aqueous halogens to aqueous solutions of halides. One has been completed for you. Okay, so this looks quite simple. So in your group 7, on top you have fluorine, and as you go down, chlorine, bromine, iodine, and astatine at the bottom. So as you go down group 7, the reactivity decreases. Okay, so the most reactive out of these three would be chlorine, followed by bromine and iodine. So chlorine would displace all of the halides that are less reactive than it. So the only thing that chlorine can't displace would be fluorine. Okay, so in this case, chlorine would displace KBr, so that would be a reaction. Chlorine would displace iodine, so that would be a reaction. Bromine cannot displace chlorine because it's less reactive than chlorine. No reaction will occur. Okay, bromine would displace iodine, so which is why there's a reaction. And finally, iodine, the least reactive out of the three, will not react with either of these. Okay, so that's it for this paper. Thank you for watching. Please like and subscribe if you want to see more. I'll see you next time. Ciao.